Good morning, everybody. My name is Yusuf Khalidi from Microsoft. This presentation is about business continuity in Windows Azure, which is a fancy word for disaster recovery and everything else you need to know about the platform itself, how it handles major failures, and how your applications should be developed and configured for high availability. Okay? So let me tell you quickly what the objectives for this session and what I hope you take away at the end. Major objective is that I would like you to understand what business continuity support we have in the platform as provided for you. This includes all the mechanisms that we do to protect ourselves and the optional mechanisms that you can use for your applications to be highly available in a global sense. The other one is that we'll discuss some methods, some templates, if you will, some ideas, how to make your application highly available. Please note, the end result here is this. The platform has a lot of functionality, but the responsibility at the end is yours to make sure your application is really highly available in a global sense. So the key takeaways is we do have quite a bit of infrastructure in the base system to replicate services, to replicate data, and so forth. But as I mentioned, you need to architect your application to be highly available. And that how highly available you want it to be is a function of your business need. It's a function of cost. This stuff does not come for free. The more important the application, the more you will be investing in making it truly highly available, and there are techniques I'll discuss in a second. For less important apps, you may want to wait for a failure before you restart and so forth. So these are just the basic ideas here, guys. Let's first start to talk about what changes with this cloud stuff. And guys, you know, we're talking about the cloud here. And some of the stuff I'm discussing here applies to Windows Azure. Or if you look at other third-party cloud providers, the basic principles in this slide really apply. The cloud does change some things. For one thing, you are now depending on somebody else to host your applications, to host your data. And the trust relationship between you and your cloud provider does change. In classical sense, you typically have your own maybe IT department, your own physical machine. You can walk down the aisle and see your machine. And you understand how it's backed up. You can see where the tape is going, where the wire is, and so forth. With this cloud stuff, with our cloud and other cloud providers, it's out there somewhere. You go through an API. You're going through a portal. So how do you trust the cloud provider? And I will discuss more about this. And it may not be you who's asking the question. It could be your customer who's asking the question, or your CIO who's asking the question. So the trust question always comes up. And that's where compliance comes in, auditing, and so forth, which, again, I will cover. The other thing that shows changes is that you need to plan for failures on multiple levels. Again, in a classical, maybe client-server systems, you have a bunch of PCs, perhaps, a bunch of servers. You know where the failures are. It's either in the PC or in the server or the wire in between them. With the cloud, we're talking about services that may span multiple geographical locations. They could be across the globe. And increasingly, the devices, the clients using the cloud are not necessarily a full-fledged desktop machine, but they are what you and I are all holding in our pockets. Smartphones, tablets, laptops, and so forth. Which is the next point, really. We all expect that services are always up and running. When was the last time you looked up your phone and say, oh, my email is not working? It's kind of funny. You expect the services to be up and running. That's a function what's happening in the industry at large. Lastly, with the cloud stuff, you actually have other options, other scenarios you can consider now. You can consider using it as a disaster recovery solution for your on-premises applications. That is not necessarily moving everything to the cloud, but using it either to back up your data or a potential site to run your applications. And frankly, it works in reverse as well. You may want to consider putting everything you have in the cloud, but still retain some services, some servers on premises to back it up as well. And I'll go through some of these scenarios as well. So it adds more options, the cloud does, but at the same time opens new questions. Do I trust it? Do I know what it's doing? And so forth. Now, some things remain the same, guys. You know, physics is part physics. You know, you still have to go through wires. There are still your business goals. Your application set is your application set. Your business is your business. So some of these things don't change with the cloud. And I'm pretty sure for some of you, maybe with a more enterprise background, I trust many of us in this room are, you know how it is to manage your application set and which ones are more important than others and so forth. So the business needs are the same. And with that, you have objectives for how fast you want to recover from failures and what is your willingness to tolerate unavailability or even potentially loss of data. So the two questions you should ask are those on the bottom of the slide. What can you expect from the platform? What can you expect from Windows Azure to help you with your job? And how can you make your application truly highly available in a global sense in the face of true disasters? I'm hoping by the end of the next hour or so, we will at least give you an idea how we covered both these points. Okay? Because the room is not that full, so if you want to stop me while I'm talking, please do so. I will leave time at the end and so forth. The big picture is actually very simple. There are 3 layers for this discussion, which I will cover in the 3 sections of these presentations. The bottom, I'm going bottom up here. The bottom one is, what do we do to make sure that Windows Azure itself is prepared for major disasters? What do we do in the platform itself to make sure that the data, applications, the people we use to manage the application, that manage the platform, are in a sense highly available? All the processes we do behind the covers, if you will. You need to ask these questions. Ultimately, if you're going to host your stuff with somebody else's, you have to know that they're doing the job. So this is the first layer. The middle layer is about optional services, functionality that Windows Azure provides that you can utilize in your application or your solution. You can mix and match the services. You can decide not to use any of them or all of them. It's up to you. But any platform should give you more services to do your job. And we're talking about data replication here, network traffic management, and so forth. I'm going to go through them one by one. Lastly, what should your application architecture look like for it to be highly available? So the bottom layer gives you a platform itself that's highly available. The middle layer gives you these services you can use, compose, to make your application highly available. But ultimately, it's the app itself, the solution itself, that has to be highly available. Okay? So I'll just go through these 3 sections right now. So what do we do in Windows Azure to make Windows Azure itself highly available? And please note, I'm using the term highly available by design, on purpose. We do not like the term disaster recovery, even though we have to be able to recover from such things. We would like to view failures as a fact of life, but also recovery to be a continuum. So we don't like those big switches of saying, oops, it's a disaster, let me worry about it. So we want to think more of it as highly available, and very importantly, your app should think about it this way as well. Again, we can discuss this point as we go along. So what do we do to make Windows Azure highly available? Covering some basic points here about the infrastructure, the geo-distribution, availability of the platform, security, and of course, compliance. For the physical infrastructure, we have been in the business of building data centers globally for a while now. Frankly, this stuff predates Windows Azure. So as early as Hotmail days, Windows Live ID, Passport, MSN Search, Live Search, Bing, etc., we have had infrastructure, global infrastructure, in data centers, in global network architecture, if you will, for quite a bit of time now as well. These include data centers which are world-class. You know the story there, I hope. Redundant power supplies, climate control, fire protection, suppression, and so forth. We have expertise in this space. What I want you to remember on this thing is that this is really a very expensive investment. It's a multi-billion-dollar investment in infrastructure, in data centers, in the people around the infrastructure, and of course in the global network around it as well. And I'll give you a global map in a second where we are and so forth. The other point I want to emphasize here is we believe that in the long term, few players can really afford to build this thing at the scale we're talking about here. The cloud requires scale. All the value proposition we speak of with the cloud, elasticity, pay as you go, etc. They're all nice words, if you will, but they become true when you have scale. To have the scale, you have to have the investment. So long term, we believe that the very large cloud providers will be few, and we're planning to be one of them, to be honest. So first thing, physical infrastructure, you have to have it. The other one is, of course, a geo-distribution. Bad things can happen in a given location. You can have a freak snowstorm that brings down power in a local location. You can have something even worse than that. You can have earthquakes, hurricanes, flooding, etc. So you have to have geo-distribution. You have to be in different places. And that requires replication of applications of data, both local and remotely. And there's, of course, tension here between the distance and replication. We'll discuss that as well. And, of course, you have to have redundancy up and down the stack. So the name of the game here is multiplicity of locations, redundancy of copies of the data, redundancy of network connections, redundancy of the application instances, if you will. Of course, you need the actual platform to have quite a bit of guarantees to you in terms of availability with an SLA, with a service level agreement. And as you know, we do have a fairly competitive SLAs that are divided by the actual subsystem in Azure. We have SLA for the compute infrastructure, for the network, for storage, for other services as well. Everything we do is a virtualized infrastructure here, guys. So in any given data center, we virtualize computation, the applications themselves, by running effectively a hypervisor on every physical machine. And we use that to isolate applications from each other. We also run a virtualized network where your applications are isolated from each other. Isolation is important because you may be running on a cloud and your competitor running on the same cloud. So part of what we do is isolation between them as well. Among all this virtualization, it's very important to have clear boundaries in there. And we do have quite a bit of those, actually. Offline, if you want to, I can point you to specific presentations at this event. We can go and review if you want to know more about the details of how we implement all of this stuff. The way they scheduled the events, unfortunately, at TechEd, one of those presentations is happening as we speak. So there's a problem here. But the point is that we have clear boundaries in the infrastructure to contain the failures. You need to have firewalls, in a sense. And I'll give you a couple of examples in a second. Lastly, is the whole notion of compliance. And I'm sure some of you really care about this. Basically, how do you know that we in Windows Azure are doing what we say we're doing? Do we have the right controls? Do we have the right people accessing your data or not accessing your data, and so forth? So the whole compliance regime, auditing, and how do you know things are actually being done the right way are important too. And again, I'll give you a description of what we do and point us to specific compliance regimes we actually adhere to. Again, you want to use Windows Azure, you have to ask us these questions. You want to use somebody else, please ask them the same questions. This is important stuff. Okay. Technically now, what do we do really? There are two techniques we use throughout the system to make it highly available, and one principle. The techniques are redundancy and partitioning, and the principle is to optimize for mean time to recovery. So redundancy. This means that everything in the system is, in a sense, replicated. You have duplicate of everything. The obvious examples is all data you write into our storage system are replicated 3 times in any given data center. And depending on which storage system you're using, we also have geo-replications we'll describe in a second as well. We also duplicate or replicate the actual services themselves. So all the infrastructure we have, all the control logic we have, all the services we build ourselves do not have any single point of failure. There's no such thing as a server running by itself and then it's sort of golden or it can never crash. We assume things crash, and they do crash. It's just physics, life. So there's no single point of failure anywhere in the system. And we know in our topology, for example, that certain things like a rack may have a single connection to it, so we view it as an independent failure domain. We expose this thing in our model so you can make sure your application is allocated appropriately along the infrastructure. The network itself is highly redundant, all the way from the rack, the infrastructure, switches, routers, to our DC infrastructure, of course. Every DC has at least 2, if not 3, global connections coming into it and so forth. So one basic technique is redundancy. Multiplicity of data copies, multiplicity of actual application instances in the systems we have. The other technique is partitioning. That is, have units of compute and storage that are separate partition units and they're separately managed behind the covers, such that if something goes wrong, for example, we roll a software update and we do a mistake, nobody's perfect, we at least confine the area in which the mistake is happening to the partition. And we are also to be able to roll it back a smaller confined unit. So let's be specific. Behind the covers, below what your applications see, below what our management APIs show, we actually build these systems using stamps of machines, clusters of machines. Think of a cluster around 1,000 servers or so. Each stamp is controlled by a replicated instance of our control software, our fabric controller, if you will. Same way we do our storage stamps. They are replicated as these stamps. After we do our testing of the software, we do rolling a patch, for example. We do also testing offline, online, etc. Everything is rolled within a stamp through multiple steps and a stamp at a time. Why is that? Again, you may have a problem. We may have a problem in our software, or something can go wrong. We found out that by partitioning this way, we are confining the failures to very nice boundaries. And the worst they can have a problem with is typically is a partition. And we can go back in time as well. Do note, all these techniques apply to you as well. You should apply them to your application as well. Question?
How would you avoid the replication mechanism together partitioning, not replicate any errors?
Definitely. So the question is, how do we make sure that, for example, replication of data does not propagate an error going forward? Short answer, as I will describe later on, is we do have mechanisms to take instances of basically a snapshot of your data in time to avoid that a future problem can basically poison all your copies. So we have mechanisms both in our Windows Azure storage layer and our SQL Azure layer to take snapshots, which they can go archive separately as well. Okay. But it's a good question, because it's one thing to get geo-replication that handles a failure here versus there. Another one is, as you imply, if you poison the data, it's all over the place. And again, that's a classical problem. Now, as I was mentioning, those same techniques should be applied by you. You should have redundancy throughout your application set, and you should think of partitioning them for a multiplicity of reasons, to be honest. Now, a basic principle is that of optimizing for mean time to recovery. What this really means is optimizing for fast initialization, expect a failure, and recover quickly from it as well. This may sound clear or obvious, but if you think about it, many of us who came from more of a traditional enterprise background, we don't usually do this. A mainframe takes a long time to boot. Typically, a mainframe or a classical scale-up machine is big, assumed to never crash. It takes time to initialize, make sure everything is fine, you're up and running, and you have somebody watching it, and I don't want it to go down. The model with cloud computing is not that. The model is everything is built out of scale-out machines, many, many machines, typically much smaller machines, smaller VMs, and so forth. Failures can and do happen. So you should assume in your application that the building blocks are relatively smaller VMs, not huge machines, and that any given component can fail, and therefore you have to optimize for it to come up very quickly. And this basic principle actually applies everywhere. For example, you may be using existing libraries from third parties or in-house. Go scrutinize them. You'd be surprised what they do. Many of them really spend time initializing, setting up their state, assuming they'll be running as part of a server that will run for a long time. For the cloud, it's different. optimized for being up and running very, very quickly. By the way, we apply the same principle to our people and our processes as well. When a failure happens, we optimize for being up and running very quickly. We do the post-mortem, the analysis of what happened later. There is time to recovery, and there is time to understand what really went wrong, and later how to rectify it. As opposed to in the heat of the moment, let's go figure it out and analyze it, and don't do that. Recover first. Trust me, it's a state of mind. It's a shift in thinking. Think about it, please. So optimize for MTTR as much as possible, please. Globally today, this is our global presence picture. And again, this is our current picture where we are actually expanding. Today, Windows Azure is in 8 sub-regions around the world. We have 4 locations in North America, 2 in Western Europe, one actually in this city, and 2 in Asia Pacific region. You specify when you are allocating your applications, your data, what the locations are. So if you go through the management interfaces we have, through the portal and so forth, you specify through account creation and location affinity specification where your application really reside. We will be expanding the global footprint. So again, this is the current footprint. And in addition, by the way, we also have a CDN network, content distribution network globally. But that's really just additional caching of data around the globe. So again, this is the current picture around the globe. Let's talk a bit about what we do in the platform to prepare for major disasters. And a key point I want to start with is that this is an ongoing investment. You have to always do it. You're never done saying, OK, I'm ready. Let's wait for a big problem. It has to be a sort of a continuous thing. Please note, guys, all this stuff I'm telling you about Azure itself, think about applying it to yourself as well. Question? I'm sorry, say the first part. Sure. The question is, are the data centers dedicated for Azure, or are they shared with other Microsoft properties? We typically share them. They're typically large. Over time, we may change how that division is. And I'll be honest with you that the 2 biggest users of data centers in Microsoft are Bing and us. And there's a long set of properties that all of them are moving to Azure. Okay. So in endgame, you're going to find basically Azure being the platform where all these other systems are running. And Bing has some specialized serving, which will remain on a different infrastructure because of the scale. We did, by the way, evolve our DC strategy because of Azure requirements. If you think about it for a second, Azure is quite different than anything else we have at Microsoft, or for that matter, most companies, because we actually host third-party applications. We host your stuff. Whereas most applications like Bing or your favorite search engines or whatever are in-house, one app, scalable application. So the security model we introduced, the virtualization we have introduced are different, and there are implications on how we design the network and the DCs. So we share the DCs, but we have evolved them. Important that I want to mention some things about the platform metadata, the data state. Everything you submit to the platform, your applications, your data, your credentials, your secrets, etc., are basically stuff we store for you. Everything we have is actually replicated. And all the metadata we replicate actually twice. We replicate through the storage system. So when we store them in our storage system, they end up being replicated locally 3 times and in a geolocation. In addition, all the critical data is copied and replicated through a different mechanism separately as well. We're just being paranoid here. So having multiplicity of ways, because you may have a bug in one path versus the other, is important too as well. So this is all the config settings, all the account information we have in a system. Now, all these mechanisms are nice, except that you have to actually test them. You have to go through fire drills to make sure they actually work. And you'll be surprised that the software may work, but the human process may not work. So, for example, we have contingency plans for all sorts of things. Our operational people have satellite phones, because you may have a snowstorm that brings down your phone system. And if they can talk to each other, we have a problem. So we have this nice big satellite phone sitting there doing nothing in case we actually need to use them. We have contingency plans for our operations center. The main one happens to be in Seattle, Washington, but we have others in the US and around the globe. So all these things you get effectively part of Windows Azure. I'm pretty sure if you're hosting with other people, they need to provide similar things as well. So preparing for people that are available in a disaster, and to make sure the communication is up and running and all the processes you need up and running are very important. And we take care of all these things. Another example, for example, is suppose we hit a bug in our software and we have to do a patch on our software. You have to make sure that the build system that builds the patch is highly available itself. And you can copy those patches fast enough from the build system in a global sense over all the machines we have. Trust me, the first time we faced this thing, we were scratching our heads saying, how do we do that? Because in shrink-wrap software universe, as you may know, we may spend 2 years building the software on a DVD. And taking a day or two to compile it is not an issue. But in the cloud, you have to compile in minutes, because you have to distribute in minutes, because you have to be up and running in maybe a couple of hours. So all these things were interesting experiences we had to go through. Lastly, capacity management. They actually go hand in hand with disaster recovery because almost by definition, when something really bad happens, you lose capacity. If we, heaven forbid, we lose a stamp or a DC, we have lost capacity. And this application has to go run somewhere else. So you have to make sure that we have enough capacity so you can run your application somewhere else. So what we do is basically we have an N1+1 architecture where for all the stamps we have extra stamps all over the globe. So we have enough capacity if we lose a DC to find enough capacity globally to run the stuff. But we have limitations. And toward the end, I'll give you a caveat slide with all the limitations we have and how you can work around them as well. Yes?
Like in a world where the risks are ever changing, how does Microsoft ensure price stability? Where, if a new threat comes in, there's more investment needed. How do you achieve that?
When you say price stability, sure. I understand. The question is about price security and how stable it is with respect to everything else we have to invest in the platform. The basic pricing model we have is very much pay as you go, but we also have other pricing models as well. We have a commitment-based type of pricing. If you commit to us longer term, you get a discount and you're guaranteed for a longer time. We also have enterprise agreements, which are typically the higher-end enterprise customers. It's what they use. So if you're a small ISV, just software developer by yourself, for example, you can just get a credit card out and be up and running on Azure just like that. If you're a big enterprise, you're going to be doing an enterprise agreement with us, which is a longer-term commitment with a multi-year commitment on pricing and volume discounts. And offline, I can give you more details. So our business is to span that spectrum, guys. While on this note, if you look at all my presentation so far is also about enterprise stuff. That's by design here. We also, for the same platform, we can host some basic websites and free and pay as you go. So the whole spectrum is part of the platform. For your question, I would look very much at the enterprise side of the house and enterprise agreements, which gives you the guarantee I think you want. Okay. So I told you, I give you actually an idea what the platform does behind the scenes. Basically, also things that may sound boring, but for some of us were truly learning experiences. From knowing how to patch a system very quickly to handle the scale in which we really work on. Now, let me move up the stack a bit. Let's talk about some services now that you can use, you can leverage in your solutions to make your solution highly available. And there are 4 building blocks I want to discuss with you. First is built-in application health management. Second one, the replication we do in our core Windows Azure storage layer. Third one is the infrastructure support we have for replication and snapshotting in SQL Azure. And the last box has to do with global traffic management, which is how to get your services in a global sense when a failover happens in a global sense. For the first box, actually, I don't have a whole presentation on this day. We have multiple presentations in this event that covers the first box. But just briefly, this is the built-in support for basic failover and recovery of any virtual machine in our system. Your application in Azure typically is a bunch of VMs written in some programming language and some model. Purely PaaS, purely IaaS VM, anything in between, you can mix and match. When a failure happens, for example, an application stops responding, or a VM crashes, or a server crash, or a network switch crashes, we have built-in recovery mechanisms for those things. That starts with basic restart of the application. You can restart the application or the VM, all the way to if a server just stops responding or goes up in flames, whatever the case may be. We will reallocate another VM for you in the fabric, in the data center. We will reconfigure the network for you. We will give you the right events about the whole thing and replumb it and make it up and running again. We only give up if we can't really do it at all, in which case you have to handle it. That basic service, so-called, we call it service healing, is built in the platform. Built in as part of base price, by the way. There's no extra feature in there. There's no extra money for that in there. And this is really very useful, especially for if you have stateless components in your application. Your front end, by the way, to be scalable and highly available is really very easy with the Azure guys. Trust me on this one. It's typically the back end when if you are doing your own data, fancy data replication yourself, things become a bit harder. So again, this thing is built in, includes things that typically today you have to worry about, like what happens if a switch goes down, or a server goes down, or an application just hangs up, and so forth. That stuff is there. What I want to tell you is, in addition to that basic local high availability, which is what this first box is, we have 3 other set of building blocks that are optional for you. First one is the Windows Azure Storage geo-replication. And by the way, everything I'm telling you today is here and now. There's no future stuff here. So today, when you write your data in our storage system, when you write into blobs, tables, or local file system, which is a remote, actually, a remote blob, your write ends up being replicated 3 times synchronously in the same data center. Okay? That's so built in. The write doesn't come back to you until it's written 3 times. In addition, we do geo-replications again across, if you will, data centers, across those subregions in the map I showed you earlier. These are true geo-replication. They're asynchronous. And we made sure that our data centers are located such that if a major disaster hits one part, it's highly unlikely to hit the other part as well. You can opt out of the geo-replication, by the way. And you get a discount if you don't want it for a given blob or a given account, if you will, the storage account. So it's on by default. The base price includes geo-replication. You can opt out of it and get a discount for that as well. Yes, please.
How many gigabytes of disk space do you need to provide 1 gigabyte of space to customers?
Raw space, you mean? Definitely. We have a very nice published paper in a highly academic conference that gives you all the details. But what we have today is we have 3 copies. So for every gig, we have 3 gig locally and 3 remotely. And we're adding something called erasure encoding, which is a Huffman encoding scheme to reduce the number of copies. I'll give you the paper. It's an ACM SOSP paper. It's a very good paper about this stuff. So again, in the simplistic sense, think of each gig has 3 gig locally and 3 gig remotely. That's a lot, I know. But with erasure coding, we reduce the number down as well. So as I mentioned when I showed you the global picture, you choose the primary location of your data when you allocate a storage account. And moreover, if you enable geo-replication, we only replicate within the same geographical location. So we keep the data in Europe or in the US. We cross the boundaries that way. Now, please note, this is asynchronous geo-replication due to physics. These are long distances. With async replication, there's a gap between your local write coming back and the remote write coming back. So there's a gap of, we few minutes perhaps, where if potentially you lose your local data center, you're going to lose some data. Again, this is physics. If you truly want a synchronous replication, please do it yourself. We don't have an option for that. Not yet. And how does this work? Well, in typical access in this system, your app or a runtime of some sort is accessing a blob through a URL. It may look like a local volume, like a SCSI drive, but ultimately it's all the same mechanism. So typically, some app is looking up through a DNS system, through a URL, which pointing to some location. And typically, we, as I mentioned, we replicate asynchronously to a remote location. That's a typical operation. If a disaster happens, we will fail over from one location to the other. And we will have the same URL still working, such that when the app looks up again the location, it will be rerouted to the remote location. Now, please note, we don't actually have an SLA for how fast the failover happens and for how long the RPO is, the recovery point objective for the data. Okay? We believe we say it's minutes. We don't have an SLA for that one yet. But just being honest with you guys. It's a function really of how the rate of writes you do. The more you write, the more we have to queue to send remotely as well. There's one important limitation, which I would say it now, I would say it again toward the end, which is the geo replication today of Windows Azure storage is only, you can only get to a remote copy if we ever declare disaster. In other words, you cannot get to your remote copy during normal operations. That's a limitation we know. Moreover, you can only get to it if we ever declare disaster. And we're not planning to. I hope not. So think of this thing as a last resort insurance. That if we truly lose a cluster or a DC, we'll turn the big switch on, and you can get your data. Question?
How often do you test that?
I believe we tested monthly, and we tested not on the live data at the moment, but on a test cluster. Take it with a grain of salt with the monthly. It could be 6 weeks, but it's really being tested very, very regularly. Very good question. We test also things, and we have a schedule for all these things because, with the best processes, things fall between the cracks. Yes? I'm sorry.
How about the regulations that say that you have to run your production environment at least 1 week a year on the other location?
The other side, yes. Sure. So the question is, how about a regulation that says you have to run your production system in a remote location at least one week a year or something? Exactly. For that, the current mechanism is insufficient. Okay, we know that. And as you see in the roadmap discussion, we are planning to make it such that you will be able, A, to cause the failover to you by yourself, and B, to be able to get to a remote copy and read only during production as well. That's on the roadmap. Okay. But I want to be very clear to you. Today, if you have to meet this regulation, you have to replicate yourself. And I have a slide again. It's a caveat, a very important caveat. We know it's a limitation, guys. Our thinking was very simple. We want to get the insurance for everybody first, then open up the policy for everybody else as well. But I have to tell you, this was a big deal to get done right. We feel good about this one. Now, some slide, which I think was mostly written by a lawyer, so a lot of words here. As I mentioned, the customer specified the locations. You can say, I want it to be in Asia, in Europe, or the US. And we can transfer data between these locations, but we're not going to transfer data across those locations. That's what we guarantee, basically. There are exceptions, and if you define print, if you configure the CDN, it will go through a CDN globally. Okay? And that's up to you. You can do it per file, per blob. I want it to be part of my content distribution network. I can get to it globally. And the other fine print has to do with we do obey legal requirements. So there's a process for that. I'm going to give you the URL on the web page or all the fine print and when we do what with your data, if you want. So this is part of the whole privacy thing. Question? I knew you were going to ask me a question.
Yeah, it's about the Americans, of course.
Yes.
The United States have
I'm going to give you the URL for that. All the information is there, actually, and we should talk offline as well. Question?
In Europe, you have 2 data centers.
Yes.
What will you do when one data center is completely lost and you're not allowed to transfer data to another?
What we will do is that, as I'm going to cover some of this in a second, is that we cannot guarantee all the capacity of the DC to be available in Europe. We cannot guarantee that. You're correct. What we will do is that a segment of the customers will have enough capacity if you reserve in advance capacity in the other data center. And the only mechanism we have to do for reservation is by having something up and running, even if it's just doing nothing in the remote data center. Again, I'm going to cover the whole thing in a second.
Will you also ask in that situation customers if they do allow transfer data in that situation?
To be honest, we haven't faced it yet. We might in that case. We will probably go to segment the customers and go down the list and basically ask you, sorry, we don't have the capacity for you in the other European location. Do you mind to go somewhere else? The only heads up is this. Physics are still an issue. So if your data was replicated to our Dublin DC, and you say, yes, I'm okay to run in Singapore, we have to copy your data to Singapore still. And that will take time. We are adding other mechanisms by to make it easier to copy the data, but we'll discuss it maybe some other time. So let's talk about the SQL side of the house. The last 2 slides were about Windows Azure storage, the basic blobs and tables, the NoSQL solution. This is about the SQL solution now, okay? SQL Azure, which is our database in the cloud. We have one mechanism called SQL Data Sync that can actually help with synchronization of data between multiple SQL instances, be they on-premises to the cloud or between the cloud and the cloud. Okay? And it helps you basically do synchronization depending on your application set. You can do it for backup purposes, disaster recovery purposes. You can do it for having a read-only copy somewhere else and so forth. It is sufficient in some scenarios, but has some limitations. Basically, it does not preserve transaction boundaries very well. And it doesn't have support for multiple versions. So it's a tool that some people have used. What we recommend instead is a set of recommendations we have in this white paper. And again, the links are in the actual presentation. One thing we recommend very much so is you have to enable resiliency by app retry logic. So this is somewhat different than classical client-server computing, where, especially if you're running a local network, your code may assume, I'm going to call SQL, it will come back. In these systems, you need to look very carefully at what your client-side code and assume a retry is part what you do. Then there's a question of the actual backup of your data. So we have a point-in-time recovery mechanism. So you can actually take a snapshot of your tables, your database every so often, and called basically a backup utility. And you can then convert them to a format, a backpack format. Then you can go back that one up. How do you back it up? You have a couple of options. You can copy it yourself. You can drop it into a blob, which you get all the geo stuff I mentioned earlier as well for you automatically. Okay. So at the moment, SQL Azure itself does not do geo replication, but as I will mention in a second, it's on the roadmap. So the best way to do it today is snapshot the data, put it in a backpack, and copy them somewhere else. Easiest one, drop into a blob. Just copy blob. And the blob will be asynchronously copied remotely, as I mentioned earlier. There's more details in the paper, but basically it's what it really says. Make sure your application does enough retries and do backup of your tables. Now, we're doing more. And this is more of a, this slide, the next one are future slides. What we're adding is we're evolving the whole HA systems in SQL Azure. So we will enable user-initiated geo-replications, and the same will apply for Windows Azure Storage, by the way. So the discussion we had a moment ago about not able to get the remote copy and the like, we're going to remove those limitations. So we'll do two things. Make sure that SQL Azure itself can do the replication, and give you the policy of how much to replicate, how often to replicate, and whether or not you want to get to a remote copy, and whether or not you want to fail over yourself. So all these are on the roadmap. And we're planning to do it both for SQL Azure and for Windows Azure Storage. Because we know very well the solution we have today is okay for true disasters, but does not meet our goal to be highly available, which is more continuous failover, if you will. And in this system, you will get a knob, a control of how synchronous you want your writes to be. And as I will discuss in a second, for some apps, you may want it to be more synchronous replication versus others. The more synchronous replication is, the more guaranteed you lose less data, but the slower you will be due to physics. So it's a function of your business need, your application need. The other mechanism we're adding is point-in-time recovery for SQL Azure. So you'll be able to take snapshots and be able to recover back in time up to a number of weeks in the past as well. And you know why you need this. Applications can go berserk. Your administrator can make a mistake, etc. This is similar to the question we got earlier about what happens with replication. You want to go back in time. So we're adding this one as well. OK. Let me switch now from data, talk about the network for a second. So we discussed remote locations. We discussed replicating the data. But suppose you actually want to fail over and go to a remote location. How do your customers find you? How does the network fail over to you? So we have a service called Windows Azure Traffic Manager that helps you to reroute traffic to your remote copy in case of failure. It actually can do two things. It can help you load balanced traffic if you have an active configuration. And it will balance the traffic depending on the geo proximity of your client to your server. We do it through DNS tricks, basically. Or the other policy is purely for failover. So it can redirect all your traffic to the main site. When a failure happens, the probes fail, it will fail over the traffic to the other site. It's available today in CTP means customer preview, basically, whatever the T stands for. It's technology. It's basically a beta. But it's available today, guys. Look at it. Again, there are two policies here. So-called performance policy, which does active, and in a sense can fail over as well. Or the failover policy, basically, which is when a probe fails for a given location, it will take the same traffic, send it somewhere else. That's all it's just a trick with DNS, basically. OK. So to recap, I discussed the platform support we have for high availability. I discussed the middleware, if you will, optional services we have for your application. Let's talk about your apps now, how they can sort of put the whole thing together. The basic design best practices are very simple. The 3 points, and the most difficult one is the last one. First one is deploy to multiple regions. That should be clear. I'll discuss in a second how much or how many of your applications should be deployed this way, but you need to be in different locations, just in case. And as I mentioned, you can specify the location both of your compute resources and your storage resources when you create your applications. A very important point, which I will repeat again. Capacity considerations are very important. Today, we have another limitation. I don't have for you a mechanism to reserve capacity in the remote location other than you having something running in there. Okay? I don't really care if you're actually running it or just idling. Okay? But the only way I can give you today to have a remote location, remote capacity in the remote location, the question I got earlier, is by you having something allocated there. Okay? Heads up about that. In the future, we may invent a reservation mechanism or with appropriate pricing, if you will. But today, if you want to guarantee that after a failure happens, that you can go to a remote data center in the same region or otherwise, make sure you have something running in there. Maybe not the full capacity, maybe a subset of the capacity, but make sure something is there so we can guarantee it's yours. Okay? The other thing, as we discussed earlier, is after a failure, you have to be able to route your traffic, your customer traffic, to your remote location. So use something like the traffic manager to do that. You can use third-party solutions, by the way, but this one actually is built in. And as I mentioned there are two policies, so-called performance policy, which will do active, both locations. or a failover policy that will go to a remote site, a primary site. When that one fails, it will automatically fail over the other site. And the failover is quite quick, by the way. The third design pattern has to do with synchronizing the data. Typically, this is the hardest one, guys. Typically, if you do your app correctly, most of your app can be stateless. You put your storage in a storage layer. You're sort of done, but not quite. You know some of the limitations I mentioned about storage stack in a second. Also, you may want to replicate your own data. So replicating the data typically where all the hard part really is. The other stuff is doable. You know what your dependencies are, get your capacity. Data is really what the whole game is about. So are all apps created equal? I don't think so. So for you who manage application portfolios or your customers or your people, if you will, most of us have something akin to this picture. This is highly abstracted, guys. But most of us have something like this. A few mission-critical applications. If they are down for any extended point of time, the business is down, right? I bet you for those apps, you're willing to pay money to make it really highly, highly available. A bunch of apps are high impact, still important, but you can probably afford for them to take more time to recover. And perhaps a longer tail of apps where they're low impact. You can redeploy them when possible, your marketing website, etc. Keep this figure in mind, because when you talk about the patterns, the pattern you choose depends on the cost you're willing to put in there, which depends on the importance of the application. So the simplistic one for the long tail of simple apps is a basic redeploy and failure, the first one on the left-hand side. You normally deploy in a single data center, that's the cheapest thing. Maybe enable geo-replication of data just in case. Have everything ready for a redeploy if something goes wrong, and when something goes wrong, just go redeploy it. By hand, you may want to reserve some capacity, not much, but this is sort of what you would do for the not very important applications. More likely for the more important ones, you can look at one of the other two solutions. Build an active-passive solution, or in the extreme, a truly active-active solution. Okay. And if you get familiar with the terms, an active-passive solution is you have your primary service running in some data center. You have your data being replicated, and you have capacity reserved in the remote data center. And the way you reserve capacity today is by having some copy running in the remote data center. How active is the other copy is up to you. Most solutions will be more about the active-passive solution, maybe a warm backup, where the data is being backed up. You may be testing it periodically, using some traffic manager to flip the traffic, all the way to a truly active solution, where you can take traffic to both. Perhaps you can take read-only traffic to both and read-write to only one of them, which you can fail over. In that sense, this is very classical disaster recovery patterns, by the way. Question?
Do Microsoft offer a DNS registration as such, where you can do geo? If you've got an application set up in Europe, say, and you've been replicating it across the US, you've got a URL that everyone goes and hits, tied to
Yep.
the IP address provided by you. Do you offer a service where, if that fails, you can switch over to?
Yes, this is what traffic manager is all about. Exactly. So this is the way it does. You basically have the public URL, it could be a CNAME, and there are actually the dual level URLs. And we will actively monitor, we probe your application in the primary location. And if it stops responding, we will flip the traffic to the other side with a very short TTL for a DNS. And the infrastructure itself takes into consideration where the clients are coming from if you want to add more of policy for performance as well. And that's available today. And it's part of any solution if you're really serious about this thing. You probably want to use it as well. Now, where do you fall on the spectrum? There's a balance here. Balance of cost, complexity, recovery time, recovery point objectives, capacity, and so forth. It really all boils down to how important is the app for you. There is a cost to have truly very highly applications that are global. So make sure you take those considerations in mind. And I'm going to sound like a broken record here. Please test it. Plan it and test it. The particular one I want to sort of point to is We discuss people, processes, and assets, dependencies. You'll be surprised what in real life what people build dependencies on a location. We had a customer, for example, they built the whole scheme. They had the primary here and secondary, everything is fine. They had to fail over and nothing worked. And they found out that they built dependency in the local routers with ACLs to only this site. They failed over, everything is fine, but the customers, the in-house customer could not fail over because the routes were not available. That's a dependency totally outside our control. And something that you can build without you knowing it's there. So unless you test it, you won't find it. So again, simple model. To summarize, for truly mission-critical applications, consider active-active solutions or active hot solutions, that spectrum in there. Make sure you have enough capacity reserved remotely, and make sure your data is replicated through us, through you directly, whatever the case may be. The bulk of them will probably fit in more of an active-passive solution, where you may have some services allocated in the remote site. You depend on some replication mechanism, and then if something goes wrong, you can fail over. Many others just redeploy on failure. It's a cost question. If money is infinite, please be on top of the pyramid, but none of us have infinite money. And guys, this really fits in the category of the clouds give you more options, locations and the like, but those trade-offs existed for a long time. So I'm sure some of you who've done this before have seen the same kind of trade-offs. Question? No. So the way you do it is, there are two sides of it. One is when you configure it, you say this part of the app should be located here and should be there, and it's purely up to you. We have mechanisms for that. You say, no, actually, you can specify sub-region. You can. So actually, the portal and the APIs allow you to specify sub-region, actually the portal. So you say, I want it to be in Western Europe, frankly here, literally in Amsterdam or Dublin. Okay? And you specify that when you create them. Okay? And the same for storage, by the way. But to be honest, this is the easy part. The hard part is the app itself has to be able to handle traffic being sent to it simultaneously or after a failover. That's the harder part. But specifying the location, that's easy. We do it today. It's purely a portal experience. Okay. So to summarize, things to think about, things you have to think about. Your availability objective versus cost, it all boils down to really cost. How important is the app? And that's sort of the spectrum we discussed, how hot your standby is like. How automatic you want the failover to happen to it. Other thing to consider is how stateless is your application? If you have the luxury of try it from scratch or to do major modification, build very much stateless applications. Put your state at the very end in your database, in your storage system. This will make all the configuration settings, all the failover stuff much, much easier. The more you have state you have to replicate, the more you have to worry about all the DR aspects of it. Of course, you also have to look at any logic that is site or instance aware. The example I gave earlier of the customer who had built-in local ACLs on the routes is an example of that. Sometimes we all build assumptions on where the application is running. So you have to remove those assumptions, because otherwise, after a failure, nothing will work really. And as we mentioned earlier, the question of do you want to synchronously replicate data or asynchronously is very much a function of your appetite for losing the data, for how much you want the pipeline to be. And again, this is purely physics here. When you are replicating data in a long distance, it takes time for the bits to actually travel, speed of light. How much are you willing to make it asynchronous and get faster performance versus more synchronous and slower performance? And the answer really depends on the kind of data you're writing. It doesn't have to be one or all, by the way. It could be some data has to be synchronous, other asynchronous. Okay, so this is the truth in advertising slide. which we discussed earlier, but I want to repeat. These are the caveats I mentioned a number of times. So as I mentioned, data stored in Windows Azure blobs and tables is automatically replicated to peer data centers, which is great, unless you opt out, of course, which you can. However, as I mentioned, you cannot today access the remote data until we, Microsoft, declare disaster. Okay? We have never declared disaster, and as I mentioned, we have no intention to do so. But things can happen. So until we declare disaster, you cannot get your remote copy. Our definition of a disaster, by the way, is a stamp, one of those clusters, or a DC unavailable for a long time. That is one we believe we cannot recover it in a long time, in which case we have declared disaster. As I mentioned earlier, our intention is to remove this limitation such that you have policy control of what's being replicated, how often you can look at the data, if you will, and when you want to go failover as well. The other limitation I want to be very clear on, we do not have automatic support for application restart or application failover across data centers. So we do also things within a DC for local restart, replumbing the network, and so forth. Across DCs, we don't do anything beyond the traffic management failover I mentioned earlier. This means, in practice, your backup copy, your passive or active copy, has to be deployed by you a priori there, and with the network configured for failover as well. Don't assume we will take your bits and configuration and just magically run them in the remote site. We might offer a service like this in the future. Today, we do not have that. It's actually easier said than done if you know what I'm talking about, if you know about it, okay? But it's easier done. I mean, you can just do it. But it's not built in at the moment. Lastly, the point I made earlier about capacity. To guarantee capacity in the remote location, you have to allocate it in advance. And the way you allocate is by running the application there, with a flag saying, just sit there, don't do anything, if you will. Of course, it's a function of your business, so you don't have to allocate the whole application. You may have 1,000 VMs in one location and maybe 100 other locations, and you figure out how much traffic the remote one should take in case of a disaster. But that's the only way you can do capacity reservation. Again, something we will, in due course, fix by giving you a mechanism to reserve capacity. But just heads up. So again, this is the slide of truth in advertising slide, guys. Now, in the remaining time, I want to cover a few things beyond the basic topic we discussed here. Okay? Which is some options you have in this space of using Azure as a disaster recovery site. And a very obvious one is, all this geolocation I mentioned to you give you the luxury of having also places to back up your data. So you can take a number of mechanisms we have. For example, SQL Azure Sync, just calling the APIs, the shell script, the PowerShell we have, or third-party tools to back up your data to the cloud. For example, there are third-party products out there, including hardware appliances. You can drop in your on-premises. They'll do local dedupe. They will figure out where your storage is and will back up to Windows Azure. And offline, I can give you some names. Yes, please. Okay, it's a question about the customers putting their physical stuff in our DCs. To be honest, we are very much a cloud platform, not a hoster per se. And the way we build our systems, by the way, these are off-the-shelf scale-out computing systems. We don't have any special anything in there. We don't have any physical appliances. We don't have any fiber channel. We don't have anything special by design. If you bring your application stack as a VM, by all means, just drop it in our system. Anything physical, we are not in that business. We're not a hoster. And I suggest either don't use it as a hoster or find a hoster for that. This point here is about having appliances on premises available from third party in software or in hardware that connect to Azure. And they can do also local things for you and back up to Azure as well. Or you can do it yourself as well. So the other way you can use Azure as a remote disaster recovery site is as a way to run your applications, your VMs, that are currently on premises. You may want to keep them on premises, but use Azure as a potential site for your recovery actions. And you can do actually the way around as well. That is, run in the cloud, but have a backup on premises just in case. To do that, of course, the last point is very important. The application architecture has to be considered. Any dependencies you have in the environment has to be resolved in advance. So an app that requires, for example, you require a fiber channel connection or a tape library and the like, that doesn't fit in the cloud, to be honest. But many apps, if you do them right, you can package them in such a way that you either run them on premises or in the cloud. And you can do this thing for capacity reasons or for disaster recovery reasons as well. So think of these options, and as I mentioned, there are third-party products already in this space that use our stuff. One mechanism we have in Windows Server 12 is actually built-in backup that can back up data you have to Windows Azure. And actually, it's a pluggable architecture. You can plug in other hosting providers if you want to as well. This has been announced as part of Windows Server 12, Server 2012. And the way it works is really it's built in the box. So if you deploy Windows Server 2012 and you have a Windows Azure account, you put your credentials in there, and that's it. Everything will be dribbled out to the cloud automatically for you. Question?
Is there any additional software to give that functionality to Windows 2008?
Not to my knowledge. It's a question, is it functionality to effectively have this information back in 2008? Not to my knowledge, to be honest. I can check for you. I know for a fact it's 2012. If you want it for 2008, you may want to look at one of the third-party solutions I mentioned earlier, which includes hardware appliances you can drop in your current network and integrate with things like SharePoint and SQL, and they can put the data up to the cloud. Now, almost done, guys. I promise you to discuss compliance for a second. This business of DR, business continuity, you'll be asked about compliance. So we have a framework for how we deal with compliance issues in general. And the framework is very simple and straightforward. And I'll give you a pointer toward the end. Next slide, actually, how we do all this stuff. Basically, there are a number of industry standards and regulations. The first blue box here mentions sort of US-centric regulations. The PCI is more international, but there are many. Every geo, region, every country has, every industry has some of those things. PCI, HIPAA, and others. What we have done is we basically created a controls framework in our platform that is quite general. So all the control points we have in our platform, from logging, auditing, knowing human processes, who can access what, role access-based control, and so forth. That's all built in our basic framework. In addition, we have an audit schedule in which we go through all our control points, if you will, and we go through third-party auditors, basically. Those audits are available to you. So you can go check what people have said. Are we meeting the compliance rules or not? We do not have a mechanism for you to audit us directly, by the way. You have to go through what the auditors said, just for us to scale. And what we have today is basic foundational compliance. So we have certification for ISO 20001 for the data centers, for the platform, for Windows Azure itself as well. And we also have SSAE 16 attestation. We'll be adding more, but it's an important point to mention here. When you look at the given industry compliance regime, ultimately responsibility is yours. That is, we in the platform will give you the basic compliance, the basic attestation for the platform itself, and the audit reports. But ultimately, you need to look at your application, your local compliance regime, and make sure the whole thing really fits together. Okay, so it's a two-way street, if you will. But much of it really at the end depends on you. And this website, which is part of the Windows Azure system, can tell you a lot more about our privacy policies, our compliance policies, some security aspects as well. There was a question earlier about this thing, and this is the URL. It's called Windows Azure Trust Center. Okay, guys, I'm basically done. So just to summarize, we have multi-level failure handling into the platform, from stuff we do in the local data center, from local restart, what have you, all the way to the geo aspects we discussed for the last hour or so. The platform itself gives you all these building blocks we discussed. They're optional. You can mix and match them, and you're going to see more of them as well. And I'll give you an idea of the roadmap for storage and SQL Azure in particular. Net, though, responsibility is yours at the end of the day to architect your application correctly. You have to balance cost with the recovery objectives, of course. And you need to be able to design it in terms of technology and people to work seamlessly through failures. Don't forget the people, by the way. In our experience, that can be the weakest link, by the way. Lastly, we're investing in the stuff. So if I get the opportunity to talk to you again in a year or so, you'll see a lot more in this space. We are not done. You guys, I have exactly 2 minutes. We've been asking questions. Thank you for your attention. I'll be here for a few more minutes and then outside and for the rest of the day downstairs as well. Thanks.